Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today, I'm going to be looking at some light and waves. So, I guess actually it's really just light today. But follow along your notes if you haven't already, and if you have any questions, let me know when we meet next. So, the first thing that we need to define is what is light? Light is any form of electromagnetic radiation that is visible to the human eye. So, it's the form of electromagnetic radiation that you can see. Now, the problem is that if I say, hey, it's a form of electromagnetic radiation, one of the very first questions I'm going to hear is, what is electromagnetic radiation? So, what is electromagnetic radiation? I'm just going to say EMR from now on because it's going to get really annoying trying to say electromagnetic radiation and trying to write it out in your notes. So, what is EMR? It is a form of energy that acts like a wave, and there are different types of EMR. Light is just one of them. Okay, so you have this little chart that you can see here. We're just going to fill them in from the most energetic to the least energetic. Okay, so the first one, what is the most energetic type of EMR that we can have? We call those gamma rays. Okay, that's what turned the Hulk into the Hulk. It's gamma radiation caused by things like exploding stars, nuclear reactors, stuff like that. Next up, we get X-rays. So X-rays, pretty dangerous, but not as dangerous as gamma rays. Pretty powerful, but not as powerful as gamma rays. Next up, ultraviolet or UV light. Again, something you're well aware of. What do people say? Put on sunscreen. Why? Because you got UV light coming from the sun. And so UV light is more powerful than visible light. So now we have the visible spectrum. We'll go back to that, but look at the tiny little sliver of light that is that visible spectrum. So, of all of the types of EMR, that's all you can see. There are plenty of other creatures out there that can actually see ultraviolet or that can see below visible. And so that would be the next one on our list. So, what's below visible? It's less energetic. That would be infrared or IR. Okay, that's what like remote controls use. Um, Thermal imaging, that's infrared. That's when you see in the in the infrared. What's below infrared though? So even below that, that would be microwaves, good old microwaves. Yep, we're talking about the stuff that's, released by that box in your house that helps reheat your food for you. Microwaves are even below infrared. And then what is even, below microwaves? That's radio waves. So radio waves are everywhere, like literally everywhere. The fact that we have so much electronic equipment around us all the time means that we're constantly being bombarded by radio waves. Your TV produces radio waves, your phone produces radio waves, your computers release radio waves. Pretty much everything you have releases radio waves. Wi Fi releases radio waves. So it's everywhere. Now let's look back at that visible spectrum. So notice it says 400 nanometers, and then it goes to about 700 nanometers. What I want you to do is I want you to color this in and color code it. And yes, when I say color it in, I mean color it in like this. So if you need to, pause it or something, feel free. But notice where violet's located, where blue is located, green, yellow, orange, and then red. Okay. So notice violet is the most energetic type of EMR we can see. Red is the least, powerful type of EMR we can see. All right, let's look at, let's think of the different sources where these things come from and then the effects and dangers of them. So, radio waves, first thing, radios, TVs, cell phones, satellites, everything releases radio waves. What are the effects and dangers? Well, technically, there aren't any. So, research has shown so far that there are no real dangers of radio waves, and thankfully, there aren't because they're everywhere. They're very slow moving, they pass through most materials, but every time it bounces off of something, it gets weaker and weaker, which is why you have, when you're driving somewhere and you're listening to the radio or something, eventually you'll lose your radio station because you're so far away from that radio tower that it's bounced off of mountains, it's bounced off of Lord knows what else, and now it's gotten so weak you just can't hear it anymore. Next up, microwaves. What releases microwaves? Well, obviously your microwave oven does, but then radar does. Not a lot of people realize that because one of the R's in radar stands for radio. And then weather forecasting, like that Doppler radar stuff, uses microwaves. So, what are the effects and dangers? It makes molecules rotate. So, actually, it makes molecules spin around. That's what microwaves are known for. And so, it can warm things up like water inside of your cells. So, it's definitely not something you'd want to be around, but it's not extremely dangerous unless you're bombarding yourself with microwaves. And I mean, again, weather satellites use it. So they release microwaves into the atmosphere and look and see, oh, how many little water molecules are rotating around, and that lets them know how much water there is inside of the clouds and stuff. Infrared. Now, infrared is what heat is. So every time someone says, oh, hey, that feels hot, that's actually the infrared radiation that you are feeling. And so we can sense it with our skin, but we can't see it. Night vision, heat seeking missiles, all that stuff uses infrared. So that makes molecules vibrate. So whereas microwaves make things turn in circles, infrared radiation makes molecules shake. And so as they shake, just like when you are like cold and you start shaking and it warms you up, it starts to generate heat as a result of that. And so it can cause burns. So you can actually get pretty burned by infrared stuff. I mean, like that's what your stove produces. So if you stick your hand on it, of course it's going to burn you, and that's just the infrared radiation. Here are some random pictures of infrared radiation of some people. Visible light, well, light bulbs, glow sticks, LCD screens. Like when you see a rainbow, that's technically caused by visible light. It energizes electrons. So now we're getting into like actual, atom stuff. It can definitely damage your eyes if you're exposed to it for too long. That's why you don't just stare directly, into a light bulb or something for too long. It can actually cause permanent damage to you. But it does. It energizes electrons. Ultraviolet, the sun. Every time you've gotten a sunburn in your life, it's caused by ultraviolet radiation. Tanning lamps, that stuff they spray, and then they use a black light, crime scene investigation style kind of stuff, the luminol. That's ultraviolet. That's an ultraviolet reflective source. It also energizes electrons, but ultraviolet's a step above, so it can definitely damage your DNA. It can unwind your DNA and break it apart into pieces. It can damage your skin. It can damage your eyes. It kills bacteria. That's why we use it to sterilize things. X-rays. X-ray machines, that's the big one. But if you've ever had a CAT scan or a CT scan, by the way, those are the same thing. Yeah, that would be an example of an X-ray source. Radiation therapy that they give to cancer patients and stuff, that would be a form of X-ray normally for the most part. What are the effects? Now, instead of energizing your electrons, this ionizes your atoms, which means it removes electrons from them and it starts to actually break apart your atoms into pieces. So, prolonged exposure can definitely cause burns, it can cause cancer, it can cause all different sorts of stuff. Last but not least, gamma rays. Where do we find those? When nuclear bombs go off, nuclear reactors produce them. Supernovas, that's exploding stars. Those are all gamma ray sources. And then what are the effects? They ionize atoms also. So they actually will remove electrons, protons, neutrons, all from your atoms. And they destroy cells. Prolonged exposure can cause burns, cancer, and definitely death. And it can be pretty quick. So, on that sad note, if you have any questions, make sure you let me know. But otherwise, that's it for the lesson.